Welcome to the Heat Treat podcast, sponsored by Matza, Creo, and Super Systems.
Hello, everybody, and welcome to the Heat Treat podcast, when we dive deep into the fascinating world of heat treatment and all the processes that shape the materials we depend on daily. I'm Carlos Torres, your host, and today we're joined by an industry expert who's been revolutionizing the tooling sector, Jim Wilbur, which is actually a personal friend of mine, and I admire him really much, and we have known each other for many years. Jim is a very seasoned tooling vendor who is currently importing high-quality tools from India, which has had a very substantial history with tooling in America, bringing a vast solution to the thermal industry. We're thrilled to have him and talk about tooling for heat treatment, covering everything from the basics to the critical best practices and optimization strategies. Jim, you're very welcome to the show. How are you today?
I'm doing well. Thank you for having me.
So, Jim, you sent me your corporate profile, and but can you share a little bit of what your company does? It amazed me that you have been for such a long time in the market, and also that it's a very family company, a lot of family values, and I've seen you growing and being very successful in the past years. But can you make an introduction of yourself and the company you work for and you represent and you lead, actually?
Yeah, well, thank you. Yeah, it is interesting. I had started in sales when I got out of college in 1984, and had my first job was selling chemicals into the ink and coatings industry. And I did that until 88, and then went to work for a small company where we were importing for a couple of different German companies and distributing throughout the U.S. And in 1993, my wife's uncle, Bill Wright, approached me about joining him. He had had a long-time associate working with him who he thought would, when Bill retired, thought the associate would buy him out and keep the business going. But the associate decided, he sent a child to college out in Kansas, and when the kid went to Kansas, he never came back. So the dad decided to start a rep firm out in Kansas, going south and west from there. So Bill had a need to bring somebody in 1993 to take his place and learn the business, and then buy him out when he was ready to retire. So that's how I got into it. But the company goes back a lot further than that. Bill had an uncle who was a rep, and all they sold back then were mesh belts. It was not just heat treating. They were used in food. They were used in cleaning. And heat treating, I guess, may have been one of the bigger parts of it. But this guy set his son up in an office in Chicago in the mid-50s. Bill joined his cousin in 1958, and all they sold back then were belts. At one point they started selling alloy, and truthfully, when I joined Bill in 1993, alloy had been the biggest part of what we were doing as far as sales. Again, they were selling foods or belts into the food industry as well, but we really have chosen to specialize in heat treating. It's the area we know and feel most comfortable.
So let's jump into discussion. We're going to talk today about tooling or fixturing, how you want to call it. But tooling is such an essential part of the heat treatment process, and yet it's often overlooked until problems arise. I'm excited to learn from your expertise today and help our listener to optimize their approach to tooling. Let's start with the basics. What's a tooling? Can you walk us through the basic concept of heat treatment fixturing, tooling a tray, and what are the key types of tools and materials used, and why choosing the right tool is so critical in the process and the right chemistry?
Well, it's critical because there are so many different heat treating processes, and you need to select the the correct material and the correct way to fixture your parts in order to minimize distortion in your parts, as well as maximizing the loading in your furnace to make it more economical. There are a lot of products, fasteners, small items that can be bulk loaded, and products like that generally are used in baskets. Traditionally, that had been rod baskets, and we've sold, many $1 million worth of rod baskets over the years, but probably 15 or 20 years ago, cast baskets got a lot more interest. The reason for that is pricing can be very competitive, but they tend to maintain their shape better. You can generally, when you're doing rod baskets, it's primarily 330. Sometimes people will go with, there are a couple more exotic alloys that people use in special applications. But the issue with that is those alloys are not readily available. There aren't enough people using it to justify the vendors making it and keeping it in stock. So pretty much the default for low temperature stuff, some people use 304, but 330 has been the go-to alloy for heat treating for probably, I don't even know how long. Longer than I've been involved.
So when we talk about 330, that's equal to HT?
It is. It's 35 nickel, right. 15 chrome.
And there are alloys above like HU that has become very popular on trays and also baskets. What's your experience with those?
Well, HT is fine if you're running a product where you don't quench. And a normalizing process can use HT without any problem. HP is another material it's lower nickel but higher chrome, so it's got more hot strength, but it will not withstand oil quenching. If it's a vacuum process with gas quenching or slow cooling, a lower grade alloy very often will work well. But if you're going to be quenching an oil in a batch IQ process, HU has become pretty much the standard material for doing that.
So now we're talking about chemical composition. Can you explain the role of the alloy composition? You mentioned nickel chrome in tooling, and how specific chemistries are tailored for different heat treatment process. What should manufacturer consider when selecting materials for their tooling? Because some of them say, I need HT without even knowing which heat treatment process they're asking for. But you mentioned that, are you quenching? Are you not quenching? Are you just doing low temperature? So can you give us just a very brief introduction about how specific chemistries are tailored from different heat treatment processes?
Well, if you're carburizing or carbonitriding, the carbon tends to be aggressive to your alloy. It's needed in the atmosphere for heat treating to impart the properties onto your parts, but it tends to attack a lower grade of fixturing. The carbon and nitrogen will tend to attack it. It attacks belts, it attacks trays, it attacks baskets and makes them brittle. And actually, if you look at a rod basket that's been run for 1.5 years or 2 years in highly carburizing atmospheres, the diameter of it'll drop. I've seen 1/2-inch rod where it's down a little thick, heavier than 3/8, but it just disintegrates. It eats it away, and it's gone, and it loses its strength because of the cross section thickness dropping. HU is one alloy that the benefit of HU compared to HT is it's slightly more resistance to carbonization, but the big thing is it better resists the thermal shock, which happens in oil. And you don't think of it really being thermal shock, you think of that more for water. But oil, when you're quenching a load from 1550 or 1600 into oil, even if it's 200 or 250 degree oil, it thermal shocks, and your alloy has to contract quickly because of the cooling. And if you don't have adequate nickel in there, it will crack pretty quickly.
What will be your alloy of choice for water quench?
Or what? Oh, well, you got to go with
That's a tough one.
truthfully, rod alloys, they'll distort more in a water quench, but they're not going to crack as quickly. If you're looking for something that'll retain its shape longer, you got to go with an HX, and you really need to control your carbon. You need to keep the carbon content below 0.4, and that allows it to remain more ductile. And but it still twists. I could show you pictures that you wouldn't believe that the material is not cracked, but just from the rapid cooling, it ends up all twisted. And yeah.
So let's talk about tooling longevity and best practices to extend the tool life or fixturing life, which is a huge concern because this is not cheap stuff. It's actually a very substantial part of the budget of a heat treatment. But I bet that you have been into many plants and you've seen companies that treat their tools, their fixtures, their trays on some ways that might scare you out, like you mentioned. But also, I believe that you have been in shops that they do a lot of best practices for maintaining and extending life of these fixturings or these trays. Are there any preventive measures or maintenance routines that you find particularly effective that everybody should know?
Well, the best thing you can do, if you're able to do it, is make your tooling reversible. Your base trays being
You mean to flip it?
Flip it, yeah, absolutely. And if you're running pusher trays, you're better to not only flip it, but to rotate it as well, just because of the pressure being applied on it. But if you have reversible trays and you flip them once a week, you flip them before they get to the point where they're drooping too much from the load, that will help them maintain their straightness. As far as extending the life on your baskets, you really can't flip a basket, but what you can do is you can rotate it so that we have customers that number their baskets in a stack, and it starts at the bottom with 1, 2, 3, 4, 5, or A, B, C, D, E. And when you tear your loads down, you put it back. The first time it's A, B, C, D, E. The next time it's B, C, D, E, A. And if you have a flat base tray and you rotate it, that really helps your baskets to remain more flat. As far as beams and fixtures like that, again, if you can load bars, anything you can do to make it reversible, it really will help you to extend the life.
And now let's talk about the most common mistakes that you see. And you don't have to give any names, no worries.
Yeah.
And how to avoid them. Let's flip the coin. What are some of the most common mistakes you see in the use of heat treatment tooling, and how companies can avoid these pitfalls to save time and cost?
Well, I'll tell you, when I first started in the business, the sales manager at the basket company I was with, told me, he said, Jim, anytime you see a forklift driver moving your baskets around, you go give that guy $20 because he's making you money. If a customer can avoid handling their baskets with a forklift, they're going to do much better. It's very hard on your alloy. You can do everything you can where you elevate the baskets to so that you're trying not to slide underneath them with the forks, but forklifts and your alloy tend to, yeah, the forks do better than the alloy does over time. I will say that.
So but to fix that one, and I do it on my heat treat, you basically just build a structural steel base support that avoids the forklift to hit the base trade, but you can actually just lift it up. Is that okay, or are you talking about conveyors or material
You're
handling?
you're much better off using a hoist with hooks and lowering. If you're able to make sure you're lifting underneath it and you're lifting straight up, yes, and that's your the charging forks for a vacuum furnace or they're, I think pretty much all of those are lift in place. So if you're able to make sure you're lifting it up and you can lowering it onto the support, yes, then you can handle it with a forklift. But baskets, trying to get them on and off trays using a forklift, it's hard on your trays and hard on your baskets. So if you can get a hoist with hooks, you'll do much better.
So now I want to switch the topic and at something very controversial and very popular right now. I know that you're currently importing tooling from India after representing a couple of American companies. What's the unique challenges and advantages that you have observed when outsourcing from this market? And how does it's compared to the traditional suppliers in terms of quality, cost effectiveness, and of course, delivery time? I mean, why India? And what are the challenges and advantages on this era?
Well, when we decided to make a change going back just over 2 years ago, um, there are other companies bringing in a number of other companies bringing in product from China, and with the geopolitical situation, we chose not to go in that direction. Especially after watching what has happened in Europe with Russia and the Ukraine and the possibility of there being long-term problems between China and Taiwan. We did not want to be in a position where we were relying on China to do it. So it is a challenge in dealing with the deliveries for people that don't plan ahead, or there are projects where they flat out don't have the time. Sometimes a heat treater will have a new job come in and they can't wait the 16 or 18 weeks that it's going to take to bring it in. But a lot of customers do plan ahead and are able to do it. And with the savings that they can get by doing it, it makes it worth their while to plan ahead and do it. But we are stocking product here. We've got a warehouse in St. Charles, and we're stocking the common batch IQ trays. It's very difficult. It would be difficult to do it for baskets because there are so many different heights and different liners. But if you need a Super 36 or a UBQ base tray, you place an order today. There's a chance it'll go out this afternoon or the following day. We try to maintain enough material. Occasionally we get we get short on certain items because we've sold more than anticipated, but
which is a good thing.
no, it's not. We always want to. You hate losing an order. Well, you hate losing an order anytime. But if we could have planned ahead to have more here, yeah. Again, it's just
So now optimization and future of tooling. I mean, as I mentioned earlier, fixturing trays, baskets. It's something that a heat treater really considers on the budget. It's a big buck item on the list, and it wears out with the time. I mean, if you have work, I mean, you want to wear it out, and you're not gonna need to keep buying. Hopefully sooner than later, because it means that you do have work in your shop. But this technology has been around for many years ago. What advancements or trends are you seeing shaping the future of tooling of heat treatment? You talked about rod baskets, then you talk about cast baskets. Are there any exciting developments on the horizon that you think the industry should be aware of? New type of chemistry? There's a lot of talks about additive manufacturing, which I don't really see that there's a big push into our industry. We mainly buy because our furnaces are very robust, and they need to have very robust tooling parts in order to support pushes and quenches and mechanical movements and fumes, and even in some cases you mentioned forklifts lifting the tooling. But what do you see as the evolution of tooling in the furnace industry?
Well, I'll tell you something. Sujan, when we selected Sujan, which is our partner, the reason we had done it, we had Casey, my brother, and I had gone to the HK show in Germany, and Sujan had a big presence at that show. We talked to I met the managing director of Sujan, but aside from talking to the ownership of Sujan, we talked to their partner in Germany and asked them about their experiences in dealing with them. And they started, I believe, in maybe 2009 doing business in the German market. And since then, I think they've got 8 or 9 different partners spread throughout Europe. But the one thing that energy has for many years has been much more expensive in Europe. And so they give more thought to selecting their alloy instead of just going with HU, which is what most people here in the US do, particularly the commercial heat treaters. In Europe, with the high cost of energy, they have thought longer and harder about other materials, even if the material is more expensive, but going with a higher grade of material, which will enable them to lighten their tooling so that nobody gets paid to heat treat their tooling. They're getting paid to heat treat their parts. And
yes, that is correct.
If you're running a load near capacity in a batch IQ, if you can lighten your tooling and fit more parts in there, the cost per pound of heat treating it is lower. So they've been doing it in Europe longer, but we now have started bringing in some higher grade alloy that does have the ability to withstand quenching in oil, but it also is better for fighting the carbon inclusion into the material. It's a higher nickel, lower chrome, so it's got more hot strength, but more impervious to carburizing, and that's something they've been doing in Europe, and we've started doing recently here. And you pay more for it up front, but when they scrap it out, and God knows they're scrapping out plenty of old tooling, you really do, you get the benefit of the higher return of what you paid for it. You get the cost of at least the metal back.
And have you found resistance in America to invest on those type of alloys that will cost you more on initial investment, but you're going to get more lifetime out of it? What's your experience on the American market trying to introduce those alloys?
We're getting more interest. The cost is higher, but people, let's face it, things have been the last couple of years haven't been as busy for most heat treaters. I'm guessing it's throughout the country, but I know in the Midwest it has not been it hasn't been like it was a few years before that, where things were going very strong. People have to look at different things to try to do better, to make, like I said, if you can run more parts and in a load and less tooling, your cost to run your heat treating is lower.
Jim, thank you so much for sharing your insights and expertise today. Tooling is such a critical component for the heat treatment industry. I think our listeners will take away a lot of practical advice from this conversation. But before we wrap up, I always like to end the podcast. You've been around in the industry quite some time, and you have family working with you. And I am a personal friend also of Willie, which I do believe are like the next generation of heat treaters. And I do believe that our industry is losing talent at a much faster pace that we're getting talent in. And this is a very technical niche industry. Is there any particular advice or story that you would like to share with the new generations of heat treaters, and how can they, get as passionate as you have been on this industry? Is there something that you would like to share with those listening to you about it?
Well, I'll tell you, I'm optimistic about it. When I started in '93, there weren't many young guys. To me, it seems like although, yeah, I was the kid. I don't know that I knew anybody younger, and I was 31 when I did it. But I do see more young people coming into it. I'll tell you that when I got into this, I really felt like I found a good place. I'd been in two different industries prior to doing this. Heat treaters are different people. I think maybe it has something to do with getting their hands dirty. There are a lot of guys running companies or running big departments that really get down and into the dirt, and I think they kind of enjoy it. And I think it keeps them grounded. And I find most of the people in this industry to be authentic and easy to get along with. And if you treat them properly, they will treat you properly as well. I got into it in '93 and never looked back. At 62, I have no intention of retiring. I don't know what I would do. I enjoy getting up and coming in and going out and seeing people. You told me I had to sit in the office every day, I'd tell you I'm done. But getting out and being with people is what makes me, it keeps me going.
Thank you, Jim, and thanks to our listeners for tuning in. If you enjoyed this episode, please subscribe, share it with your network, and join us next time as we continue exploring the amazing world of heat treatment with power players like Jim Wilbur. Until then, take care and keep innovating, Jim.